Scientists have just found a new way to travel much faster than light, something we had only dreamed about before. They think we can change how we see space to break the speed limit set by Einstein's old rules. This new idea of warp drive used to be just in movies, but now it might actually happen, letting us visit faraway stars quickly. Could this change everything we know about space? Let's discover how this new fast travel could take us to other worlds. Albert Einstein's theories of relativity have been key to understanding the universe, showing that objects with mass can't move faster than the speed of light. But here's where things get interesting. New studies are suggesting there might be a way to get around this speed limit by changing the way we think about space itself. This could lead to the possibility of traveling faster than light. His special theory of relativity has given us a complete picture of the universe by combining what we know about big objects and tiny particles. Recently, new discoveries about tiny particles have led to exciting ideas about light, gravity, and the universe around us. These findings hint that faster-than-light travel could not only help us understand the cosmos better, but it could also make traveling to other stars a real possibility, something that used to only exist in science fiction. But now, a weird signal from a new black hole might change it all. Is this our ticket to the stars, or a warning? Everyone's watching closely. The idea of using warp drive technology, which used to be just a fantasy, is now becoming a real scientific topic. This is a big shift in how we think about exploring space. Think about it, right now, space travel is super slow. For example, Voyager 1, a spacecraft launched in 1977, took 35 years just to leave our solar system. But if we could travel faster than light, the possibilities for exploration would skyrocket. We could go from being stuck on Earth to becoming explorers of the whole universe. But we have to ask ourselves, are the same laws of physics that hold us back also hiding the secret to breaking free? This concept could change the game for space travel, showing us that the physicists' speed limit might not be as final as we thought. If we stop thinking about speed in the traditional way and focus on bending space itself, we might be able to do what once seemed impossible. The potential is mind-blowing. If we could actually make this work, it would transform our relationship with space. Suddenly, interstellar travel wouldn't be just a dream, it could become a reality. We could visit distant galaxies, study planets far from our solar system, and even start colonies on other worlds. But here's the catch. This idea is still very much theoretical. The challenges aren't just theoretical, they're practical too. The amount of energy required to make this work is way beyond what we can do right now. Plus, this theory depends on the idea of negative mass or negative energy, which hasn't been seen in nature yet. That adds another layer of difficulty to an already tough problem. Still, even with these challenges, the idea of faster-than-light travel continues to captivate scientists. It gives us a small hope that we might find a loophole in the laws of physics and open the door to exploring the universe in ways we never imagined. As we explore the idea of faster-than-light travel, we're not just pushing the boundaries of technology, but also expanding the way we think about the universe. If we can achieve FTL travel, it could open up a whole new era of exploration, allowing us to study alien planets and distant stars like never before. We could truly become explorers of the cosmos. The journey to make FTL travel a reality comes with both technical and big-picture challenges. It could change how we see the world and our place in it. Even though the challenges are huge, the ongoing work to develop FTL travel keeps scientists interested and sparks our imaginations about what it could mean for humanity. One focus of this quest is Proxima b, the close planet outside our solar system orbiting the star Proxima Centauri. Recent images from the James Webb Space Telescope show us a planet that looks both similar to and different from Earth. It seems to be a rocky planet with a mass just a little bigger than our own planet. The planet sits in what scientists call the Goldilocks zone of its star, meaning it's at just the right distance from the star where liquid water could exist, which raises the exciting possibility that life could survive there. This has drawn a lot of attention from both scientists and the public. But here's where things get tricky. The planet is very close to its star, a red dwarf that gives off a lot of harmful radiation. This radiation, along with frequent solar flares, could strip away the atmosphere, making it hard for life to exist. So while the planet is in the right spot for water, it also faces some serious threats. This brings us to a key point. Studying the planet shows just how delicate the balance is when it comes to finding planets that can support life. It also highlights the challenges of exploring planets far beyond our solar system and pushes our understanding of the conditions needed for life to survive. With new ideas about speed, we now look at a bold mission to a nearby star, our next big space adventure. Our technology has made big strides in helping us study these far-off worlds. Tools like the spectrograph have given us more detailed information about the planet, suggesting it's a rocky planet similar to Earth. These advancements give us clearer data and help us better understand this mysterious neighbor of ours. Looking to the future, projects like the Starshot initiative are aiming to change space travel in a big way. The idea is to send tiny spacecraft to the Alpha Centauri system, which could let us study the planet up close in just a few decades. It's a tough challenge, but if we succeed, the rewards could be enormous, cutting the time it takes to travel to our closest neighbor in space. To understand what makes a planet able to support life, scientists study planets with very different climates from Earth. This helps them think about habitability in broader ways. It may show that life could exist in places we currently think of as too harsh. For instance, Proxima b is a planet with extreme conditions, but it pushes scientists to consider whether life could survive in environments that are completely unlike Earth. This curiosity about the planet fuels their research, balancing the excitement of discovery with the tough realities of space. But the planet isn't an easy place to imagine life. It's in a region that could support life, but it faces big challenges like severe radiation and wild temperature changes. Thanks to the Space Telescope, we've now gotten the clearest view yet of the planet, giving scientists more information about what it's like and helping them expand their ideas about planets and life. Yet the journey to the planet is another huge challenge. With our current technology, it would take around 6,000 years to reach it. This shows how far away it is and how limited our space travel abilities are right now. However, there's a project called the Starshot initiative that aims to cut this travel time down to just 22 years. It's an ambitious plan that hopes to use small probes powered by lasers, moving them at a fraction of the speed of light, to explore the planet and its nearby space. If we ever do reach the planet, it would be a game changer both for science and how we see our place in the universe. It could help answer questions about other planets and whether life exists elsewhere. And more than that, it would make us think deeply about our role in the universe, especially if we ever start living on other planets. The knowledge gained from exploring the planet could also change how we understand the formation of planets and what conditions are really needed for life. But that's not the only thing to consider. As we think about exploring and maybe even living on other planets, we face some big ethical questions. Should we change the environment of another planet? What steps should we take to avoid harming any life forms that might already exist there, even if they seem very simple? These are important questions as we consider the impact of our actions beyond Earth. Exploring the planet takes us into a new area of discovery. This faraway planet challenges us to rethink what makes a planet habitable. New technology like the Space Telescope and instruments such as the spectrograph are helping us look at planets like Proxima b more closely than ever before. These advancements are bringing us closer to unlocking some of the universe's biggest mysteries, pushing the limits of what we can do and expanding our view of life and space. The rules that govern our universe seem perfectly set to allow galaxies, stars, and even life to form. But what if our universe is just one of many, all created by black holes? It's possible that every new universe inherits some traits from the one before it. Over time, these universes could change in ways that make them more suited for life. However, even though these ideas are fascinating, they are mostly based on guesses rather than solid proof. As experts remind us, we've recently made discoveries that show just how much we still don't know about black holes. Our understanding of them, along with how the universe works, is still in its early stages. These theories stretch what we currently know to its very edge. The idea that black holes might give birth to new universes also raises big, deep questions. If our universe was born inside a black hole, what does that mean about our reality? Could there be layers of reality we've never even imagined, each with its own set of rules? The thought that we might be living inside a black hole sounds like science fiction, but it's gaining traction with some scientists and changing how we think about the cosmos. If true, it would change everything about how we see ourselves in the universe. The physical laws we follow may only apply within our cosmic bubble, with different laws outside of it. But this isn't the strangest part. This idea challenges our basic understanding of time and cause and effect. It suggests that events in the universe that created ours might still affect us today in ways we can't predict. One possibility is that the uniform look of our universe might be the result of it existing inside a black hole. The powerful gravitational pull at the edge of a black hole could mimic the same effects we see in our universe, like its rapid expansion. This theory could also help explain dark energy, the mysterious force driving our universe to expand faster and faster. If our universe is inside a black hole, this could account for the growth we observe. It's a fresh take on one of modern science's biggest puzzles. But here's another surprising twist. If every black hole in our universe could give rise to a new universe, we might be part of a vast interconnected network of realities. This idea fits with the theory of the multiverse, which suggests that there are infinite universes, each unique, making our universe just one of many branches on a massive cosmic tree. As we push the limits of space travel, we also ponder if black holes can create new worlds. What's next? Exploring the universe's biggest secrets. Despite how thrilling these ideas are, we need to acknowledge our limits. Our current technology and knowledge aren't advanced enough to confirm these theories. We still don't fully understand the centers of black holes, and our tools aren't capable of directly observing or testing many of these ideas. For now, we're working with math and theoretical predictions. But the idea that we could be living inside a black hole opens up new and exciting paths for future research. It pushes us to expand our thinking and consider fresh possibilities about the nature of reality. This theory might even offer a unified explanation for a variety of cosmic mysteries, from the Big Bang to the large-scale structure of the universe. As scientists continue to study black holes and their potential role in creating universes, we find ourselves facing a mix of new knowledge and deeper mysteries. Right now, researchers are focused on detecting gravitational waves from black hole mergers, which could give us more insight into how they behave. Projects like the Event Horizon Telescope, which gave us the first ever image of a black hole in 2019, are pushing the boundaries of what we can observe, bringing us closer to understanding these strange objects. But the road to proving or disproving the theory that our universe is inside a black hole is filled with challenges. Black holes are, by their nature, impossible to see into with today's technology. The extreme conditions near them make collecting data very difficult. If we are inside a black hole, the universe that created ours would be on a scale far too large for us to observe, raising big questions about what we can ever know and the limits of our knowledge. Still, scientists are not giving up. They are developing new ways to bring together quantum mechanics and general relativity, two areas of physics that don't always agree. With advances like more sensitive gravitational wave detectors, better space telescopes, and possibly even quantum computers, we might one day be able to study black holes in more detail and put these theories to the test. These breakthroughs could change not only physics but our whole understanding of reality, space-time, and even the process of creation itself. In the vastness of space, there are countless fascinating sights, but one that often goes unnoticed is a pair of stars that orbit each other, called a binary star system. One of these stars is a bright red giant, while the other is a cooler star with a faint bluish glow. Together, they move around each other in a graceful cosmic dance. This movement isn't just beautiful to watch. It has a big impact on how these stars grow and change over time. The gravitational pull between these two stars affects the way they age, lose mass, and even how they might eventually collapse. These kinds of star systems aren't that rare. In fact, many stars in our galaxy are paired or even grouped together in a similar way. Studying these systems gives astronomers a lot of information about how stars change over time. By observing how the stars interact, scientists can better predict cosmic events. For example, some binary star systems eventually end in massive explosions called supernovae, which are incredibly powerful and can change the universe around them. One example is a binary star system called Corona Borealis. This system has a red giant and a white dwarf, and it's on the edge of creating a huge explosion called a nova. This event could light up the night sky and be as bright as the North Star, offering a rare chance for both scientists and stargazers to witness an amazing cosmic event. But this isn't the most important part. Observing these explosions helps scientists learn not just about individual stars, but about the bigger picture of how the universe works. Each time astronomers collect data from these systems, they piece together more of the puzzle about how stars are born, live and die, and how they affect everything around them. Another key fact is that the material released in supernovae, like gold, silver, and uranium, plays a big role in forming new stars and planets. So studying binary star systems like the one made up of a star called Aneris and its smaller companion, Aneris B, isn't just about satisfying our curiosity. It helps us understand the larger cycle of life and death in the universe. As these stars continue their cosmic dance, they tell a story of creation and destruction, of order and chaos. This story not only sheds light on how stars live and die, but also offers insight into our own origins in the universe. By watching and studying these stars, we learn more about the universe and our place in it. If you like this exploration of space and the idea of traveling faster than light, we have only just begun to scratch the surface of the mysteries awaiting us.